So welcome to the lecture. This is Saikiran, Assistant Professor, Department of CST from Madanapalle Institute of Technology and Science. In our today's lecture, we are going to discuss about multi-threading. So in our course content, first we are going to see what is a task, then we will discuss about what is a thread and what do we mean by multi-threading and multitasking, what is the difference between multi-threading and multitasking, and then we will move to the thread life cycle. Then we will discuss about what are the different ways of creating the thread, and then how to create the thread by using the thread class as well as by implementing the runnable interface. First, before moving to what is a thread here, first we need to understand what do we mean by a task. Generally, a task is nothing but anything that what we want to complete or what we want to achieve. So here, first we need to understand what do you mean by multiple tasking or multitasking. Let me give one example. For example, now I am giving the lecture where parallelly I am speaking and I am able to perform writing something here on the board. So here I am performing two different operations parallelly, which is called as multitasking. So here, uh, first we need to understand what do you mean by multitasking properly. Then only we can see how to perform this multitasking. So here the multitasking can be achieved in two different ways. One is multi-processor based on the multiprocessor as well as based on the thread. So before going to see the difference between how we can achieve the multitasking by using the process based as well as thread based, first we will see what is a thread. A thread is a lightweight subprocess or smaller unit of processing. So generally here, if you are executing multiple threads, then we can call it as multi-threading. As I told you, multitasking is nothing but executing multiple tasks parallelly here. So here, this can be achieved in two different ways. The first one is process-based multitasking and second one is thread-based multitasking. First here, we need to understand the difference between process-based as well as thread-based multitasking. So when it is coming to the process-based, for example, here you can see the picture. I have taken one example. Here, one person is working on the particular laptop where he is browsing some data by using the Firefox browser and parallelly he is working on some calculator as well as he is working with Word document. This is called as multitasking. If you observe, I am performing different operations, and to perform all these different operations I am going to using the different processes. For example, here when I'm working on the calculator, it is going to using a different process. When I'm working on Word document, it is going to use a different process. When I'm working on the browser, it is going to be a different process. Parallelly, I can listen to some music also. That particular music player is a different process. So here, multitasking can be achieved based on the multi processing mechanism. In this case, when you are going to perform the multitasking by using the multiprocessing, each and every processor is going to having its own memory. Generally, switching from one process to another process, it is going to involving high cost. But here we are not going to discuss about all those things. Generally, we are trying to understand how a multitasking can be achieved by using the multiprocessing. Nowadays, what are the operations we are going to performing through the computer? So everything comes under multiprocessing. Now we will see the second mechanism how we can achieve the multitasking, that is nothing but multi-threading. So in multi-threading here we are going to having a single process. In that single process we are going to having the different threads. Let me give one example. So here I am using one Word document. In this Word document I am going to write the content. So when you are writing the content, the particular spelling of the word is going to be auto suggested. So now writing is one kind of thread operation and suggesting the spelling mistake is another thread. Okay, so in the same process parallelly different threads are going to be executed. So this kind of thing is going to be called as multi threading. So here, as we discussed, in a single process we are going to having the multiple threads. All the threads are going to share the common memory. Here you can see the example. I am having process 1 where I am having the thread 1, thread 2 and thread 3. all these three threads are going to be worked independently. So that is our advantage what we are going to get in multi-threading. As all the threads are going to be executed independently, even if any one thread got blocked, like because of the resources or some other issues, it won't affect on the other threads. Why? Because all the threads are going to be work independently, even though they are sharing the common memory. So this is the difference between multi-processing and multi-threading. In multi-processing, we are going to having the multiple processes. Each process is going to having its own memory. In multi-threading, we are going to having multiple threads in a single process, and all the threads are going to share a common memory. Here now we will see what are the different advantages we are going to get from the multi-threading. So as we discussed, by using the multi-threading, we are able to execute multiple tasks parallelly. So that is the one of the advantage what we are going to have. See here. So allows multiple operations to perform at the same time. This is one advantage. So as we are able to perform multiple operations at a time or parallelly together, the time what we are going to take in order to complete the task is going to be very less. So it is going to save the time for execution of the multiple operations. And third one is, as we discussed earlier, even though all the threads are going to share the common memory, they are going to execute independently. So here that's why you can say all the threads are independent of each other. So what is the advantage we are going to get from this statement means, as we discussed, even if any thread is blocked because lack of resources or semi or any other parameters, it won't affect the other thread executions. So all other threads are going to be work independently. So this is the advantage what we are going to get from the multi-threading, and these are the advantages. One is we are able to execute multiple operations, and second one is as we are executing multiple operations parallelly, it is going to save the time, and third one is all the threads are going to be executed independently. Now we will move to the next topic, thread lifecycle in multi-threading. So here the thread is undergoing through different states in its execution life cycle. So when the first state of the thread is going to be the new state. So from new state, the thread will move to the runnable state. From runnable state, it will move to the running state. From running state, it may go to the waiting, and next one is dead. So these are all the several states what we are going to having for a thread. But here the thread will move from one state to another state. So what, like from which state to which state the thread is going to move, we will see one by one. So generally when a new thread is born, then we can say it will be in the new state, and immediately when a new thread is created, immediately it will move to the runnable state. So when the thread is ready with the resources what is allocated for the thread, then it will be in the running state. If the thread is waiting for any other resources, then it will move to the waiting state. Then if the particular thread completes its job, then it will move to the dead state. So these are the states what we are going to having in thread life cycle. Now we will see the particular state transition for a thread life cycle, like from which state to which state the thread is going to move. As I told you, when we create an object to the thread class, then we can say a new thread is created. Okay, so when the particular object is called the start method, immediately the thread will move to the new state to the runnable state. When the run method is called internally, then the thread will move from runnable state to the running state. See here, no need to call the run method here manually. When you call the start method internally, automatically it calls the run method, so that the thread will move from the runnable state to the running state. So when the thread is in running state, we can say that the thread is executing its job. When the thread is in running state, there may be some certain conditions where it is need of any kind of resources. Then we can call the suspend method or wait method or sleep method, so that the running thread will move to the blocked state or waiting state. Suppose if the thread is in the runnable state, if stop method is called on that thread, directly it will move to the dead state. When a new thread created, when you call the stop method, automatically it will move to the dead state. When the thread is in running state, If the thread is execute all its tasks what have been allocated to it, then it will move to the dead state. Then if the thread is in waiting state for a long time, okay, then we can call it as a ideal thread. On ideal thread, if you call the stop method, it will move to the dead state again. Again, from this waiting state, if the resources what for what the particular thread is waiting, if they are available, then by using this resume method as well as notify method, again the thread will go to the runnable state. When thread is in running state, if you call the yield method, again it will go to the runnable state. Again it will come from runnable to the running state. So these are the state transition diagram for the thread. Like what are the different methods we are going to use for the particular thread for moving from one state to another state. Now we will see what are the different ways of creating the threads in Java. So here in Java, the threads can be created by using two different mechanisms. One is by extending the thread class, and second one is by implementing the runnable interface. So when you want to create a thread by extending the thread class means this is the statement what we are going to write in your program. Class myThread extends threads. Here myThread is the class to which we are going to create in the thread, through which we are going to create in the thread, which is going to extend in the thread class. And second mechanism is by implementing the runnable interface. For that we need to write the following statement in our program: class myThread implements runnable. Now we will see one by one each how we are able to create the threads. First we will look into how to create the threads by extending the thread class. So before going to discuss this thing, first we need to understand how many threads we are going to having in any Java program. If you observe in any Java program, minimum it will have one thread. That one thread is nothing but our main thread. So for each and every Java program, we are going to having a thread by default, which is going to be called as main thread. Now see how we are going to creating a thread by by extending the thread class. As I told you, if you want to create a thread by extending the thread class, so we need to take a class with any name. Here I am taking the myThread an example, which is extends the thread class. Now, whatever the job you want to execute through the thread, that must be defined inside the run method. So here, what are the thread I am going to create? It is going to executing this particular hello statement for 10 times. So this is the job which I want to allocate to my thread. That's why the job I have defined inside the run method. Now I'm creating an object to the thread class which I have created. The object name is t1. If you observe, if I'm calling t1.run, so it is like a how we are going to calling the methods of a class through an object. So now this particular run method is going to be called like a normal instance method of a class. So if you want to access the instance methods of a class, we need to use the object, right? So for this class, I created the object t1. By using that object, I am calling the run method. So in this case, there is no thread will be created. The run method is going to be executed just like a instance method. But when you calling the start method, when you calling the start method, a new thread will be created and internally it is going to call the run method. So here you need to understand one thing. Generally in thread class, we are going to having in thread class inside we are going to having a method called run. This run method we are going to overriding into our myThread class here, into our myThread class. So now, and the start method is available one of the method in the thread class. When the start method is executed, by default it is going to creating a thread and internally it is going to call the run method, so that whatever the job you defined for the particular thread will be executed. So I have taken one more example here. So now I created two classes. One is myThread1 and second one is myThread2. So for this myThread1 class, I have written one job like executing the hello statement for 10 times inside the run method. Here I have written welcome statement which is going to be executed for 10 times in the run method of inside of my thread 2 class. Now I created an object T1 to the my thread 1 class, and I created one more object T2 for my thread 2 class. So now if you observe, when these particular statements are executed, object creation statements, by this time we are having only one particular thread as we discussed earlier, which is nothing but main thread. Now at this point of time, when T1 dot start is executed, it is going to creating a one more thread. Okay, so that at this point we are having two threads, and then when the third statement is executed, T2 dot start, at this moment we are going to having the three threads here. So now if you observe, when the particular two statements executed, two new threads will be created, and all these three threads, one is main thread, and second one is T1 thread, and third one is T2 thread. All these three threads are going to be executed parallelly. So what is the output we are going to get this program is, it may be a combination of hello and welcome statements. So there is no guarantee that we are going to get the same output for each run. So when I'm running this particular program for the first time, I may get something like welcome for 10 times, hello 10 times, followed by hello 10 times, or welcome 3 times, hello 10 times, again welcome 7 times for the first time. If I run the program for second time, there is no guarantee that we are going to get the same output. So in multi-threading, so we cannot anticipate what is the exact output we are going to get. So this is the first way how we are going to create the multiple threads. And the second mechanism is implementing the runnable interface. So by implementing the runnable interface also, we are able to create the threads. In order to do that, so I am going to creating a class which implements the runnable interface. So basically the thread class is also going to be implementing this runnable interface only. So inside runnable interface, we are going to having a abstract method called run method. So in this particular case, what I am doing, I am trying to implement the run method which is available in the runnable interface. In case of thread class implemented the particular run method which is available in the runnable interface, but they have provided only empty implementation. That's why we are going to defining the job what you want to achieve inside the run method of the particular class as a uh, overriding method. So now coming to this one, implementing the runnable interface. As I told you, this run method is an abstract method, and I am going to defining the job of the thread inside this run method. So now if I want to create the object for this class, and so that I am going to creating an object. So generally what we will do here, we are going to creating the object to the particular class, and if I'm call the start method, it doesn't work. It is going to give an error. Why? Because in runnable interface, we don't have any kind of start method. This start method is available with thread class. So whatever the object we are creating for the class which is implementing the runnable interface, that object must be registered with the thread class. Then only it is possible to call the start method by using that object. So that's why this particular way of calling the start method is illegal. So that's why here I have provided the correct way of how we can create the thread by implementing the runnable interface. First, I have created one object for the particular my thread 1 class which is implementing the runnable interface, and I have created one more thread for my thread class on my thread 1. Now if you observe here, what are the thread which I created T1 here, that I registered, like sorry, what are the object I created for this thread class, that I registered with the thread class here. So now when I'm registering that particular object with the thread class, I created one more object T1. When I'm calling this T1 dot start, T1 dot start, then whatever the run method I have defined inside the my thread 1 class, it is going to be called and it will be executed. So in this case also, if you are creating multiple threads, then what will happen? If you are running them, we cannot anticipate the exact output what we are going to get. So here you need to understand the what is the difference while creating the threads by implementing the runnable interface as well as by extending the thread class. So thread class is already implemented the runnable interface. So what are the object we are creating for the class which is extending the thread class, on that object directly we can call the start method so that the new thread will be created. But if you want to call the start method on the object of the class which is implementing the runnable interface, it doesn't work. Why? Because it is not registered with the thread class. So first we need to register the object of the particular class with the thread class by using this particular statement like this. Then we can use this particular object to call the start method so that the multiple threads will be created and they can be run parallelly. So these are the different ways of creating the threads. I hope you understand the concept, like what is a thread and in how many ways we are able to create the threads. So thanks for watching.